Hey, what's up, compressed air friends? Hey, so as you guys know, I'm a pretty strong advocate that service techs, when we are doing startups and things, we should probably be checking the electrical side of things, making sure it's all done correctly, up to code, all that fun stuff. The problem we run into is it's partly a problem of confidence. I think a lot of us, rightly so, don't really understand the code book well enough to try and go head to head with the electrical contractor when something appears to be out of sorts. And so, even the iFix Compressors app, as good as it is, that motor electrical data portion of that app is really, really good. The problem with it is when it comes to the breaker size, the fuse size, it only gives you the maximum allowable by code. And so you might have a branch circuit for an air compressor that is 100% code compliant, but because they didn't use the maximum size breaker, you might get yourself into trouble arguing with the electrician over that. And so what I'm going to show you guys tonight is all the major AI apps out there now, Gemini, Claude, everybody. They all have an agentic feature built into them, which is to say you can kind of have a separate entity within your AI that can carry out certain tasks. And they can get pretty elaborate. You can give them access to knowledge bases and different kinds of information and stuff. We're not going to go that far. But what I've done is I've come up with a simple prompt that you can copy and paste into the instructions of any of these, whether it's in Gemini, they call them gems, Claude calls them projects, whatever AI you like. I've tested on a few of them. This prompt works flawlessly on all of them. So in the comments section, I'll paste the prompt, and then here in just a minute, I'm going to show you what the prompt actually returns using the AI. But what it does is it's no different than the iFix Compressors app. Really, you're just going to give it your voltage, so 230 volt, 460 volt, whatever it is. You give it your voltage, and you give it the horsepower of all of your motors involved, and it will return. It tells you the minimum ampacity of the circuit, the wire size, the ground size. But then this actually gives you a range. It gives you a minimum to a maximum size breaker, minimum to a maximum size fuse. That way we kind of eliminate that issue of, well, it's not the maximum, but it is still code compliant. And then below that, it actually kind of gives you a breakdown, a summary of the calculations it used, where it pulls them from the code book, all that kind of stuff. So again, I'll put the prompt into the comments that you can just copy and paste, and you're off and running. So real quick, I'm going to show you guys how this works. All right, so let's get this party started. So this is the gem that I built within Gemini. It's just called Motor Calculations. And so down here, the system prompt that's pasted in the notes is what's running in the background of this right now. And so when I come down here, all I'm going to tell this thing is we are running 460 volts AC, and we have a 75 horsepower main motor. Whoops, not Pain motor. Come on, Rob, type main motor, and a 3 horsepower fan motor. That's all the information I'm going to give it right there. Boom. And it's going to think about it for a little bit. Maybe for a long bit. There we go. So right here at the top, we get our quick reference summary. It's going to tell us our minimum circuit ampacity is 124.8 amps. Phase wires are going to be 1 gauge copper. Ground wire is going to be a 4 gauge. Breaker range anywhere between 125 to 225 amps is okay. Fuse size anything between 125 to 150 amps is okay. Now, when we come down here to the detailed specifications and breakdowns, so it's going to show us that it calculated a 75 horsepower main motor at 96 amps per NEC table 430.250, which is the correct value to use. Fan motor, 3 horsepower, 4.8 amps per. Okay, that's all correct. So for our minimum circuit ampacity, it's going to take the FLC of the largest motor times 1.25, add the smaller motor on top of it. We come up with a value of 124.8. So, circuit breaker range. Minimum size is just above our minimum circuit ampacity, which is 125 amps. You put a 125 amp circuit breaker on a 75 horsepower compressor, I will slap you, but it is legal. For our maximum size, once again, we take the largest motor, FLC, times 2.5, then we add the smaller motor on top, we come up with 244.8. So per NEC, we can run that down to a 225 amp breaker. Same with our fuses, same calculation, but we use 175 instead of 2.5. We come up with 150 amp for the largest size fuse. So that's what it's going to return. And if you feel like this is going to be helpful to you, then feel free to copy and paste the prompt. If you go into your AI of choice, be it Gemini, Flash, whatever, and if you're using Gemini, just say, hey, how do I create a gem? And it will tell you how to do it step by step. It's incredibly easy to do. Don't be scared. So, like I said, I've tried this same prompt on a number of different AIs. They all accept it. It works the exact same on all of them. So whatever your favorite AI is, figure out how to make an agent in it. Like I said, in Gemini, they're called gems. In Claude, they're called projects. I did not do Grok or Chat GPT, mostly because I don't like them, but I'm sure they have something as well. So anyway, there it is. See ya.